Hi there everybody, this is lesson 3.1.2 and today you're going to learn about how to find missing parts in similar figures or when you have an enlargement of another figure. This is problem 314 in case you're following along in your book. If you're not, that's okay. Just follow along with what I do here and you'll be fine. Here we've got a kind of a C shape. The height is 8 and the width is 6. And when we enlarge it or dilate it, the height became 24 and the width became 18. So we're going to compare the heights with a ratio. You can see it up here, 24/8. And then we're going to compare the widths with a ratio as well. Now, I put the height of the big one over the height of the small one. So I put the big one over the small one. So I can do that on the other one as well, or for the other ratio. The big width over the smaller width. And 24 divided by 8 is 3. 18 divided by 6 is also 3. Those ratios are the same, and that will be the case. Anytime you have an enlargement of another figure, those ratios are going to be the same. In this case, each side just became 3 times as big as the size in the original. So let's take a look at another way we can compare the dimensions here. So we can also compare the height to the width. So let's take a look at those ratios. Height over width. Now, I did height over width for the smaller one, so I got to make sure when we compare these that we do height over width for the other one as well. And when you reduce these fractions, this fraction reduces to 4/3. 8 divided by 2 is 4. 6 divided by 2 is 3. This one also reduces to 4/3. 24 divided by 6 is 4, and 18 divided by 6 is 3. So whether you are comparing the heights, 24 over 8 and 8 over 16 and the widths, or you're doing height to width, those ratios are going to be the same. See, we got 4/3 for both of these. So we're going to use that to find a missing side here. So here we've got an enlargement of our original C. The original C was 8 high and 6 wide. Now our enlargement is 20 units high, and I can't really think of a number that when you multiply 8 to get 20. It's not a whole number, it's a decimal. So we need a way to be able to find the width of that figure. So there's a couple different ways you can do it. Let's start by doing height to height and width to width. So we're going to do 20 over 8. And we know that has to equal the ratio that the widths give us. Now I did the big height over the small height, so I got to make sure I do the big width over the small width. So I'll have to have x over 6. Now we've got a proportion that we can solve. 8 times x is 8x. 6 times 20 is 120. And then we solve that equation by dividing both sides by 8. We get x equals 15. So this side right here must be 15 units long. Now we didn't have to set it up like this. You saw in that last example we did height over width. That has to be the same for each one too. So you could have set it up like that. You could have said 8 over 6 equals, so that's height over width, 20 over x, height over width for the other one. And then we could solve that one the same way. 8 times x is 8x. 6 times 20 is 120. And look there, we got the same equation we did before and the same answer. So either way you set it up, you're still going to get the same answer. And there are other ways to set it up. You could have said 6 over 8 equals x over 20, or 8 over 20 equals 6 over x. There are lots of ways to set it up. All of the ways that you set it up correctly should give you 15 for an answer. If they don't, it's not set up right. So you do have to be a little careful. That's it for today. Hope you have a great night, and we'll see you in class tomorrow. Bye.